Process 1 to 2 is isentropic compression of an ideal gas. Okay. Now, for isentropic equations, okay, kalau siapa yang tak ingat, kita go back to our previous lecture. Okay, quickly just to go back. There are a bunch of equations related to isentropic processes that we can use. Okay, so I highlighted this in the class. Basically, you have two options or two methods to be used in calculating any isentropic processes. First, by using the approximate analysis, okay, by using or by employing the constant specific heat. Okay. The other one is by using the approximate analysis. Okay, now, okay. So basically, approximate analysis, first one. Okay, this is again approximate analysis. The other one is by using the exact analysis. So this, or it's not this. So this and this is the exact analysis. Okay. So what's the difference between these two? Okay. Approximate analysis over here and the exact analysis. Approximate, okay, in this case, they use approximate. Okay, this is the set of equations that can be used for isentropic processes or the approximate analysis. So first method. Approximate ni, dia approximate sebab the value of K here. The value of K, kita tahu K is Cp divided by Cv. And the value of K, most of the time for air, kita guna 1.4. Okay, kenapa? 1.4 ni ialah the value of K at 300 Kelvin. Kalau kita ada processes 1 to 2, for example, yang temperature difference dia greater than ataupun besar, large temperature difference. This approximate analysis dia off, dia slightly deviates lah. But still you can use it. Dia approximate, nama pun approximate, dia tak tepat. Tapi advantages of this approximate analysis is that it is quicker and easier to be used. Okay, kenapa? Nanti saya tunjukkan example. Kenapa dia quicker? Okay, compared to, for example, okay, remember this is approximate. The other one is the exact analysis. The exact analysis is the one utilizing the relative pressure and relative volume. Okay, remember kita ada R, relative. Exact analysis, dia more accurate, okay, but tedious. Kenapa? Sebab you kena use table and then you kena interpolate most of the time. Okay, so nanti kita akan tengok example. Previously, if you remember, kita tengok example for auto cycle. Previously in the class, we did one example. This particular problem, okay, saya use or I utilize the exact analysis or exact method. Kenapa? Sebab for this particular problem, the problem specifically asks for us to account for the variation of specific heats of air with temperature, meaning that our Cv and Cp now is dynamic. Dia tak boleh kita assume our Cp or our K lah sebenarnya, our K is equal to 1.4, which is taken at T equals to 300 Kelvin. Okay, they assume at 300 Kelvin. But now this question, they ask us to account for the variation of specific heats, meaning that kita, dekat setiap temperature kita kena cari. So from the exercise, if you remember, kita tengok banyak interpolation, for example, interpolation. And then sikit-sikit interpolation. So untuk setiap state, you kena interpolate. So jadi proses tu lambat lah, panjang. Okay. Tapi setiap proses ada pro and cons, macam saya highlightkan tadi. Untuk approximate, dia memang senang, very quick, you tak perlu guna table. Okay, tapi dia punya accuracy kurang lah. So it depends on the problem. Kalau problem asks you to use ataupun to account for the variation of specific heat, then you have to use the exact analysis. Okay, so let's go back to our question. In this question, this particular problem, dia tak tanya pun atau dia tak ask for you to consider exact analysis or approximate analysis. Okay, jadi which method to be used? Sebenarnya you can use both method. So I can write it down. Remember, this is exact analysis, first method, ataupun first option. Then you have the second option, which is the approximate analysis. Okay. Most of the time, kalau student tanya, saya kata it doesn't matter. Okay, but for the purpose of our study, saya suggest waktu saya buat first auto cycle, kita guna exact analysis. For this particular problem, kita guna approximate tengok. Because approximate, dia memang sangat-sangat cepat. Okay, for example, kita nak dapat T2. Okay, so for T2, if we use the equations given for approximate analysis, kita tahu what is T1, kita tahu V1 divided by V2 is R, and we know K over here is 1.4. So if you just substitute this, you can get your answer to be 953 Kelvin. What happens if you use the exact analysis, the V over here? Okay, for example, kita tahu V1 and V2, this is given, and kita tahu juga VR1, sebab the temperature was given kan. So T1, the temperature was given 27 Celsius plus 273, so you akan dapat 300 Kelvin. So, untuk exact analysis, okay, remember, exact analysis ke approximate analysis, these are for isentropic processes only. Excuse me. Okay. Untuk for this particular problem, if you want to find the temperature, the T2, by using exact analysis, what you need to do? First, you rearrange, you get VR2 equals to V1, V2 multiplied by VR1. What is the value of VR1? You can check from table. Okay. Which table? Ideal gas table lah. Okay. A70 if I'm not mistaken. Okay. So you can check from table. So once you dapat the ni, you substitute, you get your answer. Okay, you get your, let's say lah, VR2 equals to something. This is in terms of VR2. So how can you find this value? Then you have to go back to the table. You have to interpolate. So for example, if we open our table, okay, let's say here. So we have PR, we have VR over here. Let's say lah, you find your VR somehow. Okay, let's say the value of your VR is, let's make it easy. I'm just putting a random number over here, please note. Just putting a random number. Let's say your value of VR is 231, for example. So what you need to do is you go to table, this table A17. You have to find in the column of VR your particular value 231. So kalau kita tengok sini 231. Okay, this is VR. Okay. 231 is located somewhere between these two values, between 236 and 223. So the value is in between, meaning that you have to do interpolation. You have to interpolate in order for you to get your T value over here. And your T value must be in between this lah, 440, 450. So instead of just substituting the value, now you have to do interpolation, detailed analysis, okay, using the table. So I would suggest, if possible, always go for approximate analysis unless the question asks you to use the exact analysis. Okay. So similarly, for P2, you can use the approximate analysis. You substitute the value. Okay, this is again R. Okay, remember, there is a difference, K minus 1, K over here. You don't have to memorize this particular problem. In the test, for example, appendix will be given, but in the appendix, there will be a bunch of equations. So you have to know which one to be used, okay? But you don't have to memorize. All this will be given, but you need to know which one to be used, okay? So you substitute the value, you get your answers for P. Okay. So the next process, 223, is a constant pressure heat addition. Remember, this is not isentropic process, so you cannot use isentropic equation. Isentropic equation is basically VR, additive PR, and then you have to use this now, the approximate analysis, V1 divided by V2. These are all isentropic equations. So the other options for non-isentropic processes, okay, for 223, usually you can use the ideal gas equation, this one. Okay. All right. So since we all know the value, okay, we can find T3. T2 was calculated before. V3 divided by V2, this is RC. Okay, cut-off ratio. So you get your 3, T3. Next, for 3 to 4, again, this is isentropic expansion. That's why always write down the processes involved. Okay. You use isentropic equation. Again, this is approximate analysis. Okay. V3 to V4, we calculated the volume before. Similarly, this is calculated before. K, we know it is 1.4, and we have T3 and P3 from before. Okay, so you substitute, you get the value. This is isentropic equation. Okay. Next, we want to find the net work output and the efficiency. Okay. So for efficiency, excuse me. For efficiency, okay, this is the standard form or standard equations that we use to find efficiency. So we know we need to find W net and Q in. So the definition of the W net is just Q in minus Q out. All right. So in this case, because we are using capital Q, we need to find M to cross out. Okay, M, we can use the PV equals to MRT. P1 was given, P1 was given. R is the universal gas constant available in the property tables. Okay, and this is T1. Okay, R, again, it will be given. You don't have to memorize. So once you calculate M, we can find Q in first. So Q in, if you look from the diagram over here, right? So Q in is just M H3 minus H2. Remember H, because this is a work boundary process, okay, constant pressure. So you get M H3 minus H2, but we know from H, we can get the following equations. Okay, we can use MCP T3 T2. Okay, just to highlight again, how do we get CP? This is from DH dt. Okay, all right. So from here, okay, we calculated M before. Okay, all substitution lah. You have all the values from before. Next, for 4 to 1 is a control volume heat rejection process. Control volume. So you are dealing with in terms of U. M U4 minus U1. Again, to highlight, CV equals to du dt. So that's why from U, you can get MCV T4 T1. Okay, it's not CV, yes. Sorry, this now is CP, this one is CV. Yeah? Okay. Remember, control volume, there is no area under the curve, so no work done. So it is in terms of U. H here, just to highlight again, in case you forgot, okay, over here. Work boundary is PV, and Q in, we have P change of V plus delta U. So PV plus U is equals to H. So that's why we have H or Q in because of the work boundary. Just to highlight again, this is from thermo 1. Okay. So you substitute all the value, you have Q in and Q out. Okay, so again, just substitute the value. So we get our efficiency roughly about 63%. Okay. Next, for the mean effective pressure, okay, the definition of MEP is W net divided by Vmax minus Vmin. Okay, so Vmax in our case is the volume at bottom dead center, so V1. Vmin is the volume at top dead center, which is V2. So we have V1 and V2 from before. That's why it's not highly, I emphasize on the units. Always write down the units because you need to do unit conversion. Otherwise, your final value will be some nonsense when your units. So you need to do unit conversion in order for you to cross out the kilojoule. Okay, all right. Alternatively, this is MEP by using the definition of Vmax minus Vmin. But okay, from previous example, in the auto example problems, we use the following expression. We can basically substitute. We know V2 is equals to V1 divided by R. Okay, so if we take V1, sorry, this is not VR, this is just V1. So if we take V1 out, okay, we get V1 1 minus 1 over R, which in this case we know what is R. So your value should be close to one another. So that's why I want to show in this example problem, there are alternative options. Isentropic equations, for example, you have approximate analysis, exact analysis, MEP itself, you can use the definition, you find the volume, or you simplify, you use this following expression. Okay, so let's stop for 2-3 minutes. Any questions? Kindly ask. Anyone? Okay, so that means semua orang faham Alhamdulillah. Okay, so kalau tak ada, kita continue dengan Brighton cycle. So always remember lah, sebab dalam kelas, previously, saya tak tunjuk example problem sebab saya just fokus for the lecture, and then example problems ataupun problems ni kita tengok masa tutorial. But student dia kata dia tak faham kalau tak tunjuk example problem dalam kelas. So saya tunjuk at least satu lah. Sebab if you notice, kita ada tight schedule. Our syllabus needs to be done or needs to be finished by 14 weeks. So if I just cover example problems dalam kelas, we will never finish with our syllabus. So that's why I put out selected problems for tutorial for that you can attempt. Sometimes apa yang kita belajar dalam kelas, kalau you tak tengok how it is being solved ataupun implemented dalam problem solving, dia susah nak imagine. So that's why it's important to do both, belajar teori dan tengok how the problems can be solved. Okay. So let's now move to Brighton cycle. Okay. So just take a few seconds to read this question. Okay, so let's have a look at this question. So a gas turbine power plant operating on an ideal Brighton cycle. Okay, so the keywords here is a ideal Brighton cycle. So you need to know that the cycle that you are dealing with. We have a pressure ratio of 8. Okay, so write down. First information given, RP is P2 divided by P1. Then the gas temperature is 300 Kelvin at the compressor inlet, and 1300 at K, 1300 K at the turbine inlet. Right now, saya suggest waktu saya kata, always remember, first kita tulis what's given to us and put it in terms of diagram. Okay, now, for auto and diesel cycle, mostly kita guna PV diagram. It's easier for us untuk solve that particular problems using PV diagram. For Brighton and for Rankine, which already uploaded the lecture notes for Rankine cycle, chapter 10, we mostly use TS diagram because it simplifies our understanding of visualization. You are still okay untuk use PV diagram, that's fine. Okay, but I'm just giving you the options. Basically, kita selalunya guna TS or TS diagram for Brighton and Franken. Okay. Now, dia bagi kat kita the gas temperature is 300 Kelvin at the compressor inlet and 1300 Kelvin dekat turbine inlet. First, we need to know dulu. Kalau student dia tak boleh visualize, for example, what is turbine inlet? Is it at 3? Is it at 1? Is it at 2? So kalau you tak tahu kat turbine inlet tu state mana ataupun proses mana, then that's a problem. Sebab tu always write down the process to help you understand. Okay, in this case, saya draw two diagrams. First ialah components diagram. This is component diagram. Okay, to highlight basically untuk Brighton kita ada compressor, kita ada combustion chamber, ada turbine dan juga ada heat exchanger. So in terms of TS diagram, it is on your screen lah. This is your TS diagram for Brighton cycle. So kita label one by one. So 1 to 2 is the isentropic compression for the compressor. So we have W compressor, W in, and then 2 to 3 is the constant pressure heat addition process. So label, we have Q in, takut kita lupa. And then kita ada isentropic expansion. Okay, 3 to 4. So we have W turbine work out. And then 4 to 1 is the constant pressure heat rejection process. We have Q out. So if you have all this, baru nampak lengkap. Okay, now you know 1 and 2 is the compressor. So compressor inlet, you can label over here 300 kilopascal, 300 Kelvin. Baru nampak. Then turbine inlet is over here at state 3. So 1300 Celsius. Kelvin. Okay. So baru nampak, baru you know turbine kat mana, compressor kat mana. Okay. Alright. So I think that's all that was given to us. We are required to find gas temperature at the exits of compressor, which is state 2, and also exits of the turbine 4, and back work ratio, also the efficiency. Okay, so let's have a look. Okay, so determine the gas temperature at the exits of the compressor and turbine. Okay, so from the diagram, we understand. We understand that we need to find T2 and also T4. Okay, so 1 and 2 is the isentropic compression. Okay, T1 was given. So if we refer to table A17, we can get this particular value, H1 and PR1. All right. So if you notice, in this problem, which method are they using? They are using the exact analysis method. Okay, why? Because we are looking for the value of PR. Okay, so if you look over here, they are using the exact analysis. Okay, because we want to find PR2 based on P2 and P1. This is RP, and we know what is PR1 from here. We just find from the tables. Okay, so from here, substitute the value, you get T2. Okay, so if you notice, kalau kita guna yang approximate analysis tu, you don't even need to use the property tables. Okay, you can just substitute the value, you get your answer T2 straight away. And then from T2, you open the table, you find H2. Okay, so in this case, just to show you alternative ataupun options yang student ada untuk guna. Dia tak kisah actually method mana, as long as it is right. You guna untuk, for example, 1 to 2 isentropic process, you guna isentropic equations. Okay. 3 to 4, again, is the isentropic expansion. T3 was given to us. Okay. From here, if we go to table A17, we can find H3 and also PR3. Remember, we are using exact analysis. Okay, you can find P4 relative pressure at 4. Okay, by using this equation, we know what is PR3. Okay, we calculated or from the table. Okay, P4 divided by P3. Remember, if you look at over here, the definition of pressure ratio, RP is equals to P2 divided by P1, which is almost the same or equivalent to P3 divided by P4. Okay, the pressure ratio. Now, what we have over here is P4 divided by P3. So, instead of RP, you have 1 over RP right now. Okay, so that's why you have, this is 1 over RP, 1 over 8. RP was given. This is from before, from table. Okay, now you find your PR4 value, then you have to go to table. So just let's have a look. Okay, if we go to our table on the left, PR4 is 41.36 P. Let's say the pressure 41.36. Okay, 41 should be located in between these two values. So we are dealing with P. So 41 should be between 43 and 47. So you have to do interpolation. Okay? So when you interpolate, okay, you're supposed your value, your temperature should be between 780 and 800. Betul tak? So you tengok sini, your answers is 770, which is in between 780 and 800. So see, if you want to use exact analysis, you basically involve additional steps. Okay, so you have to use interpolation, not just once, really twice or at least 3 or 4 times, okay, along the way. Okay, but in return, it gives you a more detailed or exact value. Okay, so sometimes student tanya, apa relevannya, kenapa ada approximate, ada exact. Okay. Sometimes, for example, kalau you work in the industry, your boss ask you, okay, kita nak nak design satu sistem ni, dia bagi parameters, okay, could you please design a boiler or a simple rating cycle, for example, a Brighton cycle. Okay, sebab dia nak basically just estimate, you use approximate analysis, you tahu exit berapa, inlet berapa, but then bila you nak fabricate ataupun manufacture that parts, nak order, you need detailed analysis, then you use the exact analysis or exact method. So it depends on the situation that you are in, bila nak guna. Okay, alright. So okay, just to give you some idea how the values or the answers are different if you use exact or approximate. So if you look over here, so I just attempt just to use the approximate analysis for, okay, kita nak calculate just now T2. Okay, so T2 divided by T1, okay, P2, P1, K minus 1 over K. Okay, saya nak cari T2, kita tahu what is T1, sorry, this is T1. Kita tahu RP, P2 divided by P1, and we know the K is 1.4. So if you substitute, you get your answers of T2 543. So kalau kita tengok kat sini, kalau ini ialah exact analysis, kalau kita approximate, dia akan dapat 543 Kelvin, which is not that bad. Okay, it's very, very close to one another. Okay, so again, as I said, it depends on the particular problem lah. Sekarang ni you are still learning, so it's up to you. Unless the question memang specifically ask you to find or to use the certain method. Otherwise, I suggest as a student, dalam test you are against rushing against the time or semua, use the approximate analysis. Okay, alright. So I think we're done with H4. Now B. We want to find the backward ratio. If you remember what is the definition of backward ratio, is basically kalau kita turbine, kita ada work produced by the turbine, almost half of the work produced by the turbine is being used to rotate the compressor ataupun to move the compressor lah. So this is turbine, W turbine. It's being split into two. Satu ialah untuk power up the compressor. The other one is W net, which is basically connected to shaft lah. So basically, almost half of the power, in theory, from the turbine is being used to compress the substance or working fluid. Okay, only half, the other half is for the total out W net. Okay, so by definition, backward ratio is the percentage of power in, compressor in, divided by turbine out. Okay, so W com in, compressor in, divided by turbine out. So if we look from our diagram, compressor is 1 and 2. So we know it is H2 minus H1. Okay, we calculated H1 and H2 before. Similarly, for turbine out is over here. So it is H3 minus H4. Okay, so we have all these values, substitution, and then when you put it in the equations, so you notice almost 40% of the turbine work output is used to drive the compressor. Just imagine almost half. Okay. All right. So that's the backward ratio. I think, yes. Then finally, we have thermal efficiency. Again, I think I don't have to remind you. Basically, thermal efficiency by definition is W net divided by Q in. Okay. So we have all the information H3 and H2. Okay. So just substitute, and then your efficiency of the system is roughly about 42%. Okay. All right. I think that's all I want to cover for example problems. So now I open for questions from students. Anyone? Dah semua okey ya? Kalau semua okey, so now I leave you guys untuk buat soalan lah. Kalau you ada apa-apa pertanyaan, just give me a shot. Okay? Alright. By the way, before I forget, insyaAllah maybe next week or the next 2 weeks, kita akan ada our first official punya quiz. Just take note. And I have also uploaded the lecture notes, the recording for the lecture notes for the ranking cycle yesterday or the last 2 days. Okay, so please have a look and be prepared for the quiz. Thank you.
Thank you, sir.
Okay. Soalan from Nak. Ya Abdah Nak. Okay. Bila kita nak guna PV diagram dan bila kita nak guna TS diagram. Okay. As I said, you can use both. It doesn't matter. You can use any of the diagrams, PV or TS diagram, for all the cycles. But as a preference, I suggest or I prefer to use the PV diagram for auto and diesel, and then TS diagram for Rankine and Brighton cycle. It just is easier, I think, for me. But I think if your preference, if you prefer to use PV or TS diagram for any of the cycles, it doesn't matter. It's okay. Yeah. Okay, as long as you paham. That's the purpose of it. Okay. From Akmal, salam. Ya, attendance sila isi link yang diberikan. Betul. Itu saja. Ada soalan apa-apa lagi from students? Hopefully you guys tengah cuba menjawab soalan. Ni kalau saya suruh buka video ni mesti ada yang tengah makan nasi lemak lah, kutia goreng ke roti canai ni. Okay, so apa A tu untuk 9.6 9.6 dan 9.7. A merujuk kepada actual. S ialah isentropic. Actual tu berlaku sebab deviation in because of the irreversibility. S ialah isentropic, the best outcome possible. So kalau straight line isentropic, kalau deviation tu yang dotted line tu A sebab actual cycle dia tak akan dapat straight. Okay. Kadang soalan Abdah, kadang-kadang confuse macam mana nak tengok table. Maksud saya kalau soalan bagi pressure dan temperature, yang mana kita kena utamakan? Okay. Kalau kamu tengok table kan untuk saturated table ataupun ideal gas, kita ada option untuk tengok mana-mana. Pressure boleh, table temperature pun boleh. Ini soalan termo satu ni Abdah. Itu dia tak ada keutamaan, tak ada. Kalau dia bagi dua-dua, it's up to you. Tapi kalau tanya saya, it depends. Contoh kalau kita nak check, kalau masa termo satu, kan kita nak check location ataupun state tu berada di mana, compressed liquid, saturated mixture region ataupun superheated region. Kalau macam tu, it's easier untuk tengok in terms of temperature. So for example, kalau kita nak check lokasi dia kat mana, yang macam kita nak isi table tu kan, so kita go to table figure, table pressure, and then dekat pressure tu kita tengok T set dia berapa. Sebab kalau kita compare T yang diberi dengan T set, kalau T yang diberi ialah lower than T set, saturation temperature, then kita punya state tu berada dekat compressed liquid lah. Kalau dia berada higher than T set, tu maksud dia dekat superheated. So I think dia depends on kita punya pemahaman. Dia tak ada keutamaan. Okay. Okay sir, memang soalan akan given to A to S ke student kena interpret? Again Syazwan, saya tak faham apa interpret kamu ni ya. Ini soalan kalau kamu tengok, ini dalam form textbook dan lecture notes, memang A ialah actual. Actual ialah yang deviation tu, dotted line. Kalau S refer to isentropic, maksud dia yang straight line tu. Isentropic ialah ideal yang kita belajar. A ialah benda yang akan berlaku dalam real life. Dia tak akan dapat straight line, actual. Kalau dalam quiz, kalau tak clear tak apa, boleh tanya ataupun saya akan detailkan. A ialah actual, S ialah isentropic. Soalan from Zailan, kalau soalan tak suruh guna metode apa yang saya prefer, approximate atau exact? Okay, saya tak ada preference. Again, macam saya cakap, it depends again of course lah. Kalau dia tak suruh metode apa yang saya prefer, dia tak ada preference untuk saya, dia untuk apa yang kamu yang nak buat. Kalau saya suggest lah, ni suggestion, guna approximate sebab dia lagi laju. Kalau yang tak, soalan yang tak minta apa-apa kan. Sebab kalau guna exact, dia memerlukan interpolation, dia calculation pun lebih. Interpolation tu banyak kali. Jadi dia makan masa. Okay. Jadi saya tak ada preference. Actually apa yang student faham sebenarnya. Kalau kamu prefer untuk guna method yang exact, nak cari relative pressure, relative volume, that's okay. Go for it. Maybe kamu lebih confident, lebih senang bagi kamu untuk guna table kan, nak extract, nak interpolate, that's okay. Okay, terima kasih soalan. Okay, lagi ada Ada lagi soalan? Silakan, silakan.
Pasal soalan MEP tu kan, dia ada formula W net, lepas tu bahagi V darab dengan 1 tolak 1 per R. Satu tolak 1 tu dia nak kira macam mana?
1 tolak 1.
Ada dalam formula MEP.
Aha. So 1 tolak 1 per R lah. R tu ialah kamu punya compression ratio. So kamu substitute lah 1 per R berapa, and then 1 tolak value tu lah.
Tolak 1.
Saya share screen balik ya. Sekejap ya. Okey. So soalan tadi macam yang tadi MEP tu. Okey. Kita tengok. Bisa lah. Okay. So saya rasa ni kan soalan
Sir.
gampang lah.
Dia ni dekat auto.
Dekat auto.
Sorry.
Okay. So apa persoalan kamu?
Okey, faham. Saya salah tengok.
Okay. Alright. Boleh ya?
Saya ingatkan 1 tolak 1, rupanya dia 1 tolak 1 per R.
Ya, tu kena pakai surat mata kot bang.
Dah pakai dah, Sir?
Dah pakai dah, kena tambah lagi power tu. Okay, terima kasih soalan. Okay. Apa? Ada soalan lain tak? Pelajar lain. Thank you.